In the next few slides, we will show 6 examples of applications where Kisling has helped customers overcome an assembly manufacturing issue. Our first slide in the e-motor section shows different applications that are covered by Kisling. From the outer case or housing assembly, sealed with an instant gasket material or RTV. The magnet bonding, in this example they're pocket magnets with various structural adhesive and anaerobics. Retaining compounds for the bearing to the shaft. Metal shims or the windings. The outer case with the through nuts and bolts using thread lockers. And the winding encapsulation with various potting compounds. This slide highlights a few advantages of adhesives over the conventional fasteners. No mechanical securing elements are necessary. The entire bonding surface area absorbs the shear and tensile forces through it. Increased design freedom allows for different material combinations. Full interface connection to dissipate the load. Reduced connection gap. Corrosion protection and sealing, no damage to interface at the contact areas. Equilateral force distribution, no stress peaks. Cost saving on machine engineered parts as intolerances can be compensated for. No feather keys, wedges, pins or similar additional tooling required. Good electrical installation, improved heat management due to thermal conductivity, improved noise, vibration, harshness performance, and excellent chemical and thermal resistance. The next slide is a short video of a typical motor assembly. The magnets have a 2-part structural adhesive applied and then positioned and fixed in place. The housing and mating face are aligned and sealed with a flange sealant. And finally, the retaining screws are inserted and secured using a thread locker. I'll now run the video. So we start with applying the 2-part adhesive through a static mixer. This is a 50 ml cartridge to the outside of the magnets. The magnets are aligned, pressed firmly in place against the housing. Now we're applying a flange sealant around the interfacing from the housing to the cast. These 2 parts are coupled. Then we apply a Kisling thread locker and we bolt the whole assembly together. Now we have a finished sealed unit. This is typical of a standard motor assembly using Kisling products. This slide is just a reference slide to indicate some of the top selling products for that electric motor assembly. You will get a copy of the presentation after the webinar finishes in PDF format, and you'll be able to go back over looking at the part numbers, looking at the descriptions, and you can then match or ask for samples of these products to test for your applications. In the next few slides, we will show 6 examples of applications where Kisling has helped customers overcome an assembly manufacturing issue. Here is an actual success story. The customer was bonding pocket magnets, and the challenge was to remove the heat curing stage, as this increased the production time and added additional equipment in the form of the ovens. We needed to speed up the cure schedule to under 30 seconds, and the customer wanted to go from a 2-part structural bonding application to a single component solution. They needed to allow the magnets to be positioned with no adhesive for a low viscosity material to be run in afterwards. Kisling's solution was a single part UV cured anaerobic ergo 2453. We achieved a single component application that was automated. We removed the heat cycle and additional ovens. We increased productivity and throughput by 66%. We reduced the pocket gap down from 0.5 to 0.1 and reduced the overall amount of adhesive applied by a factor of between 3 to 5. Here is a short video to demonstrate the UV anaerobic product. The metal block has the anaerobic material achieved and applied. For this purpose, we've used a glass plate so we can demonstrate the UV light penetrating, curing, and within 2 to 3 seconds, the bond is achieved. Here is another success story where we had to find a solution for bonding on E-coat. The requirement was to have an automated, simple application that cured at room temperature very quickly. The solution was to apply an anaerobic material, ergo 4451, and an activator, ergo 4920, into the housing of the motor directly. Firstly, a ring of anaerobic material was dispensed using a swirl applicator to form a precise line. We can demonstrate this with the video. You will see that the swirl applicator is moving down. The anaerobic is being dispensed. We have a nice even film of anaerobic which would be down inside the pocket. The application is repeated with an activator that films a second layer just below the anaerobic. And then when the magnets are inserted, the two materials are mixed together, forming an instant bond. Here is a one-part solution plus activator for bonding a commutator onto a steel shaft. In the bottom right-hand image, you can see two dots of material being dispensed. One is anaerobic and one is an activator. When the COM is slipped into position over the two materials, they mix together, giving an instant bond. This method takes around 20 seconds. It's 33% quicker than the standard method and increased productivity by 33% with no performance compromise. In this application, the customer needed to have a very long open time due to the size of the motor. The solution was to offer a product we call no mix. Conventional two-part mixing systems have a catalyst and a resin that are mixed together in a preset process with a time that cures typically in 3 to 8 minutes. With no mix, you add the resin to the area where the magnet is to be placed and the catalyst to the underside of the magnet. When the two parts come together, the cure schedule is activated. The advantage is that as long as the two coated surfaces do not come into contact with each other, the material will not cure. This gives you an infinitely long open time for assembly. In this example, a two-part epoxy was used to allow a long processing time of 45 minutes. The material needed to withstand temperatures in excess of 180 degrees. And due to low-cost production machining, we also needed to fill a gap of 5 mil. The recommendation here was our two-part system, ergo 7440. High temperature resistance was met at 180, excellent chemical resistance, and also it was black. Gap bridging of 5 millimeters could be achieved easily, and the whole application was realized in a timely manner. Finally, this example is for a linear motor, where the magnets are already magnetized prior to assembly. As in the previous slides, we used a no-mix product, applying the resin to the base plate and then the activator to the magnets. As you push the two together, you get an instant cure with the assembly. This does not allow the magnetized magnets to pull. Just holding them for a few seconds gives you a perfect adhesion. Again, as previously, this table is a quick reference for you to look back over later on, which would help you make a decision which would be the right chemistry and solution for you. Just 2 slides now to show an overview of the anaerobic product range and our RTVs. In this slide, we have listed 9 products that have been instrumental in the manufacture and production of electric motors. The anaerobics, the RTVs, are all listed for reference that you can go back at a later date to check, and you can use them in accordance with the bonding slide and reference number here to look what would best suit your applications. Moving on now, we would like to show a few slides to give examples and information of the production and assembly of stamped metal laminate cores. In this slide, we have 3 traditional methods of assembling laminate cores or shims. Punch pack. This is the mechanical fixing that laminates lock together using tabs or interlocking folds. Some of the concerns of failure here are electrical shorts from the paint or varnish delamination. We have welding the laminates together, but again this can be fiddly and requires fixtures and jigs to correctly align the stack prior to welding. Backlack. Many people should be aware of the backlack system, which is the method of applying varnish, baking the stack. This requires high temperatures, additional equipment such as ovens and applicator systems, and all these things can be costly, and typically the process time is long and time consuming. And finally, we have bonding. Bonding the metal shims to the laminate cores. This offers a reliable, speedy process with good mechanical strength, excellent insulation properties, and can be integrated into the punching tool, as I will explain on the next slide. So this slide describes how to automate and speed up the bonding process for laminate cores. The process involves inserting the first sheet with no adhesive. Then the second sheet will have the adhesive on the top and the activator on the bottom, and we will build up the shims accordingly with adhesive, metal and activator, and as they get fed into the stamping tool, they are compressed together, and the result is that the shim will come out fully bonded. So we have adhesive, metal, activator, adhesive, metal, activator, thoroughly stamped through, providing a finished shim. The process described on the previous slide was made possible with a new product developed by Kisling, VP0124. This was used in combination with an activator. The technical performance of this development product are here for your reference. And we're actively supporting and looking for people to test and try this development product before we take it out into the marketplace in the coming months. Finally, I would just like to share with you a new development product in the thermally conductive potting resins. Many motors and windings and assemblies are finished by impregnating the voids and end terminations. This is fine for oil-cooled motors, but where we have an air gap, the heat dissipation is poor and leads to excessive temperatures in the motor operation. The solution in this case is to fully encapsulate the winding to the motor body with a thermally conductive potting resin. This allows the thermal energy or the heat to dissipate away from the windings through the thermally conductive resin to the body or heat sink, reducing the operating temperatures and increasing the longevity and the performance of the motor. The product we developed, or we're developing for this, our new thermally conductive resin, is VP152 and VP153. It's a conductive potting encapsulating running at 1.2 watts per Kelvin. As you can see, the pot life, the viscosity, etc. are all listed on this slide for reference. And again, we would like to encourage anybody that's doing encapsulation to contact us with a view to testing this product in their motors. Thank you for your time today. I hope you found the seminar interesting and informative. Should you have any further questions, feel free to contact myself, a member of our team, or a local distributor. They will all be happy to help with you. We would now like to invite you to join a question and answer session. The mute function will now be removed, but you still have to unmute your microphone on your screen to be able to ask a question. I will hand you over to my colleague, Michael Karcher, our Market and Application Engineer. He will be happy to answer your questions. Thank you for your time. Have a great day from Kisling and the team. Thank you, Michael.
Hi, Craig. Thanks for giving the presentation. So as mentioned by Craig, you can ask any questions you want right now, and I will try to answer them. So please feel free to speak. Otherwise, as mentioned by Craig, we will also share the contact details of the technical team so that you can approach us after the webinar and get in contact with us in order to talk more about technical details if you wish. If you have a question, please make sure that you unmute your microphone, otherwise I won't hear anything. Well, it seems that there are no questions coming.
Hello, my name is Patrick. Can you hear me?
Patrick. Yes.
Hi. One question, please. Which products would you recommend for inserting magnets into pockets? Which specific Kisling products?
Well,
I saw on your slides you were showing the success story of this ergo 2453. Are there other Kisling products, components for inserting magnets in pockets?
yes. So the 2453 is a dual cure system which helps you to cure in the first step via the UV light, and then afterwards the reaction is as an anaerobic reaction. For sure, depending on the requirements you have in terms of temperature range, processing time, how the process itself looks like, there are other options we can propose, either another anaerobic system or even a methacrylate system, which also cures at room temperature with a very short pot life. So at the end of the day, we would need to look together at your process and at your requirements of the applications in order to select the right product.
Okay, and for high temperatures, for 175 degrees and more,
well,
are there?
Yeah, so looking at the 2453, it goes up to a temperature of 175 degrees C, the temperature range. So this could be a suitable solution for your application. Otherwise, we have another anaerobic system, which also goes up to 175 degrees C, which is the 4453. Or we change to an epoxy system with even higher temperature, maximum temperature, going up to 180 or even short term up to 200 degrees C.
Which would that be for 180 degrees and higher?
This would be the ergo 7440. For sure, here, if you cure at room temperature, it will take much longer. So we would need to look into your process and see whether a heat curing is possible to accelerate the reactivity and the time of curing.
Okay, and in comparison to the ergo 1810, how can you compare the ones you just mentioned to ergo 1810?
Yes, the 1810 is a fast curing system, but the temperature range we only propose going up to 150 degrees C. If you're looking for a system which has a higher temperature resistance, we would not propose this one, but would propose another system.
All right, okay, I understand. Thank you.
You're welcome. Are there any other questions? If not, then as said, we are going to share with you some contact details so that you can approach us separately with your request and your requirements or questions. And otherwise, if there are no more questions, Craig, I would propose to close the session and say thank you to everyone for joining this webinar about our adhesives for e-motors and e-mobility applications, and have a good day.
Thank you, Michael. Thanks, everybody, for joining us. Thank you and bye-bye.
Thank you. Bye.
Thank you.